Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. The problem is nearest exit from entrance in maze. You are given an m cross n matrix maze 0 indexed with empty cell represented as a dot, that is empty cells, and walls represented as plus. You are also given the entrance of the maze where entrance is the entrance row and entrance column. Denotes the row and column of the cell you are initially standing at. In one step you can move one cell up, down, left or right. You cannot step into a cell with a wall and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance, and the exit is defined as an empty cell that is at the border of the maze. The entrance does not count as an exit. So return the number of steps in the shortest path from the entrance at the nearest exit, or -1 if no such path exists. So actually what we can do is we want to find the nearest exit. So considering this as a graph problem, we can either move in four directions. So moving in four directions, if we are able to find the first exit, then that is going to be our answer. So the minimum number of steps, either we can do a DFS or a BFS on this graph. So by doing a BFS is the clever way here, because we have to find the minimum number of steps. So doing a breadth first search will obviously give our minimum number of steps when we reach the grid. That is, we are going in level wise fashion. So first, if in one step we can reach either here and here, in second step we can reach here, likewise we can go. So we can do a level wise breadth by BFS, and once we have reached the boundary in the case, the row which is having either 0, the row which is having a 0 or something 0 to call -1, or call minus row -1, or 0 to call -1, or 0 to row -1 0, or 0 to row -1 call -1. So these are considered to be the exits, right? These consider this, there are no breaks. So these are all the exit cells. These are all the exit cells, and these are all the exit cells, and these are all the exit cells. So if we are able to reach one particular cell like this, 0 to 0 to call -1, and row -1 0 to call -1, like this, all these four conditions to be true, all this either of the one of the four conditions is true, then we know this are the exits. So if we are able to reach at this particular point, then obviously what we can say is we can just return our answer. So consider we are at this position 1, 2. So first we can put the entrance into our queue. Then we will do a BFS traversal, and we will explore the four directions. While we are exploring the four directions, we are seeing that if that particular cell is not a brick, and if it is going to be an exit, then the distance that we are traveling from the previous point to this point is going to be our answer. That is nothing but the distance plus 1, the previous distance plus 1. So we can just code the approach first. What we are going to do is we will take the row. Row is nothing but the base dot size, and call is nothing but base of 0 dot size. And also I'm going to store a row, a call, and column number, and the distance. So I should have three information into my queue. So I will have a struct that is going to store int I can say it as row number int call number, and int distance. So I will define a queue of triplet queue, and I will push the initial values entrance of 0, entrance of 1, and the distance initially is 0. Now what we can do is we can run a VFS traversal while my queue is not empty. We also need a visited matrix, so we can also define a visited matrix, because we should not visit the cell which we are visiting again. So we, instead of changing the original maze, we can have a visited vector of size row and a vector of int size column, which is initially 0. So while we can also make the entrance of 0 visited of entrance of 0 comma entrance of 1 is true. So first what we can do is we want to go level wise. So what we can say is int level int size is equal to level dot size, sorry, queue dot size, while size minus we want to do this particular level, we want to pass this particular level. So auto curve is equal to q dot friend and q dot pop. So now we can go in 4 directions. So to go in 4 directions, we can just define del x of array of size 4, which is 1 0 minus 1 0 in del y of size 4 1 comma 0 0 comma 1 minus 1 comma 0 0 comma minus 1. So we can go in all the 4 directions. So int k equals 0 0, k is less than 4, k plus plus. So int new x is nothing but cur dot row number plus del x of k, and int new y is nothing but cur dot call number plus del x of k. If this is going to be valid in the sense the new x and new y is inside the boundary. So valid new x new y and row and call, I'm going to pass this if it is going to be valid, and if it is not a brick, maze of new x new y is equal to an empty cell, is equal to an empty cell, and it is not visited yet. Visited of new x and new y. If it is not visited, then what we can do is first we can visit that new x and new y. Once we have visited this, what we can do is we can say it as q dot push off new x new y and curve dot distance plus 1. But we also want to check whether this is inside in the boundary. So if my new x is equal to 0, or my new x is equal to rho minus 1, or my, or else we can have it as is exit. Is if this new x and new y is an exit, then we can just return the cut dot distance plus 1. That is going to be our answer. At the end of the day, if I am not able to find any exit, I can just return minus 1. So we have to define the valid function and the exit function only. So we can just do here bool valid. It takes a row number, it takes column number, and the total number of rows and total number of column. Return if row is greater than or equal to 0 and row is less than row, and c is greater than or equal to 0 and c is less than column. So this is the valid function, and we want to check whether it is an exit. This exit is nothing but int new x, new y, and the row and the column. Int r, int c, int row, int column. So this exit is nothing but return if my row is 0, or if my row is equal to row minus 1, or my column is 0, or c is equal to column minus 1. So this is going to be my exit. So hope this is clear. So now let us try to run our code. Okay, actually something has happened. Sorry, here it should be before this. Okay, we have got our correct answer. Okay, let us observe what is happening here. Sorry, actually here it should be cut dot row number plus del x, and here the cut dot column number plus del y of k. I have made a mistake here. Now let us try to run our code. Okay, it gets accepted for all the cases, and let us submit the code. Hope it gets accepted. Hope you like the solution. The time complexity here will be an order of m cross n, and the space complexity will be an order of m cross n, and we are using a queue, so it is not going to be exceeding m cross n, so you can say it as m cross n. Hope you like the solution. Let us see in tomorrow's LeetCode Daily Challenge, and then bye.